Hello everyone, welcome to the new video of our series Virtualization with Hyper-V. In this video, we are going to talk about the virtual machine settings. So these settings consist of the virtual machine RAM, virtual machine hard drive, network adapters, integration services, and processors, virtual processors for the virtual machine, checkpoints. All these settings will be explained in this video. So let's get started and walk through each and every setting of the virtual machine. So let's open Hyper-V Manager now. You can just type in here Hyper-V and the Hyper-V Manager console will come up. Oops, looks like I typed it wrong. Let's type Hyper-V and here it is. So we have got the Hyper-V console up and running now. We can see that these are the virtual machines that I have created in my lab. Now we can right click on any of these virtual machines to be able to see their settings. And these options we have already covered in our previous video, so you can see the link in the description for the previous video so that you can understand the functionality of each and every option that we have in here. So let's click settings and it will open the settings of a particular virtual machine. Now these settings define what a virtual machine is built of and how we can change those settings. So let's say we need to change the RAM of a virtual machine, we need to change the hard drive size, or we need to add another hard drive in a virtual machine, or we need to add a virtual network adapter, or maybe we just need to remove an adapter. So all those things, all those operations will be done from this console. So that's called virtual machine settings. So the first one in here we have under hardware. So from the drop down you can select any virtual machine that you have currently in your Hyper-V host so that you can see the settings of their virtual machines, and you don't have to close it and right click on each and every virtual machine. You can simply just select it from this drop down. Let's say we need to check the settings of TGDC-2016 virtual machine. Now the first option is add hardware. In the right side you will see that we have got SCSI controller, network adapter, legacy network adapter, fiber channel adapter. These are the components of virtual machines that we have already talked about, that what exactly they do. So if we need to add another hardware to this virtual machine, then we will need to use add hardware. So let's say if we need to add a new SCSI controller to our virtual machine, we can simply just come in add hardware option and then select SCSI controller. Right now we cannot change it because our virtual machine is in running state. So because we are using Gen 1 virtual machines, so we will need to turn off the virtual machine to be able to change these settings. If we would have been using Gen 2 virtual machines, we don't have to turn off the virtual machine and we can simply just change the settings while the virtual machine is running. So that's the difference between Gen 1 and Gen 2. You can add a new network adapter from this option. If you want to add a legacy network adapter or a fiber channel network adapter, you can add all these hardwares from this option. The next one is BIOS. So we have already talked about that BIOS is one of the firmwares that we have in our computers. In case of a virtual machines, we also have a BIOS because we are using Gen 1 virtual machine. So that's why we only have BIOS as an option in here. If we would have been using Gen 2 virtual machine, we will have BIOS as well as UEFI as option. So because Gen 2 virtual machine supports both BIOS and UEFI, where Gen 1 only supports BIOS. Now in the right side you will see that we have startup order. Let's compare it with a physical computer. So whenever we start up a computer, the computer checks that what is the order of boot process. If we want our computer to be booted from the operating system that we have installed on it, that we don't have to change the boot order. But let's say we have a CD plugged into our computer and we want our computer to be booted with that CD because the CD contains an operating system. So to be able to do that, we need to change the boot order. In a physical computer, to change the boot order, you will need to go to the BIOS settings of that computer. If you change the boot order and keep the CD option at the top, then your computer will search for the CD. And if it finds that there is an operating system in that CD, it will boot with that. So to be able to change this boot order in a physical computer, we can go to the BIOS settings, and depending on your vendor like Dell, HP, Sony, Depending on your vendor, your boot settings may change. Generally, it is F11 or F12. When you start the computer, you keep pressing F11 on your keyboard and you will enter into the BIOS settings. And in there, you can change the startup order. In the same way, in a virtual machine, we have the startup order in here. So CD, IDE, legacy network adapter, and floppy. Let's close these settings and open the settings of virtual machine, which is currently turned off. So we have got this TG client 1 turned off. We'll go to the settings of this, and you will see that when we go in the settings of a turned off virtual machine, we have all these options enabled. So we can add. So let's say that we want to add another network adapter to this virtual machine. We can simply just select network adapter, click add, and it will add another network adapter. You will just need to click apply and then it will be done. And you can connect this network adapter to any virtual network or any virtual switch that you have created on this Hyper-V host. So let's cancel it for this time because we don't want to add any network adapter for now. Let's go in settings. Next setting is memory for the virtual machine. We can define RAM in here. So whatever RAM we assign in this box will be assigned to that particular virtual machine. So if we add, let's say 4 GB in this case, so we need to mention it in the terms of MB, so it will be 4000 MB. If we do not enable dynamic memory, then this will be called fixed RAM for this virtual machine. So whatever RAM you provide in this box, that will be called fixed RAM if you do not enable the dynamic memory. So what will that mean? That this virtual machine will lock up 4 GB of RAM from your physical hardware. And even if this virtual machine is not using the complete 4 GB, if it's just using 1 GB, this 4 GB will still be locked up and no other virtual machine will be able to use it. Other hardware, physical hardware won't be able to provide it to any other virtual machines. That's why it's called fixed RAM. If we enable dynamic memory, in that case, we can define the minimum and maximum RAM for the virtual machine. So you can see in here, we have defined 512 MB as minimum and 10, or let's say we change it to 10,000. That will be 10 GB maximum limit. So this virtual machine, when it will be started, it will be using the minimum RAM that it will be assigned, and then it can go up to the maximum RAM that we assign to this virtual machine. So let's say that this virtual machine is running an application which has a workload which requires around 5 to 6 GB of RAM. Now let's say that the workload increases and this virtual machine requires more RAM. So it can increase its RAM up to 10 GB on its own. We don't have to increase it manually. This virtual machine can go up to 10 GB of RAM. And let's say that the virtual machine is not using 5 or 6 GB of RAM, it's just using 2 GB at some point when the workload is not that much. So in that case, the whole 10 GB will not be locked up. Your virtual machine will only be using 2 to 3 GB RAM, and then the rest of the RAM can be provided by the physical hardware to any other virtual machines to load balance or to provide them their RAM amount. So that's the difference between the fixed RAM and dynamic RAM, that in case of fixed RAM, the RAM gets locked up by the physical hardware, and in case of dynamic RAM, the RAM does not get locked up. And the rest of the RAM, which is not being used by the VM, can be used by physical hardware for other virtual machines. Then we have memory weight setting in here. So we can provide high or low memory weight to any virtual machine. Let's say that this virtual machine has the weight as high. So that means this virtual machine may be running in critical application. So that's why it requires more RAM, or it requires RAM on priority. So we can set the setting to high, and then this virtual machine will be provided the RAM by physical hardware on priority. So that's how the memory works in case of virtual machines. We can increase or decrease the memory for any virtual machine. In case of Gen 1 VMs, we have to turn off the virtual machine, but if we are using Gen 2 virtual machines on a 2016 hardware or 2016 physical host, then we don't have to turn off the virtual machine. We can simply just change these settings while the virtual machine is running. Next is processor settings. So in our previous video, we talked about how virtual processors work and how we can assign virtual processors to a virtual machine, and how many virtual processors can be created depending on the physical cores that we have on a physical hardware. So on this page, we can change the number of virtual processors to be assigned to a virtual machine. So let's say we want to change the virtual processors for this virtual machine. Right now it is assigned one virtual processor, and it depends on your physical hardware, on the physical cores that you have on your physical hardware, that how many virtual processors can be assigned to your virtual machines. And then you can also use the resource control options to be able to load balance the processors in your Hyper-V environment, and you can change these settings as per your requirement. Next is IDE controller. So in virtual machines, you will find IDE and SCSI controllers. Gen 1 virtual machine support IDE as well as SCSI both, while Gen 2 virtual machines only support SCSI controllers, because SCSI is an upgraded version of IDE and it provides more benefits than IDE. So because we have Gen 1 virtual machine, this one, so we'll have IDE and SCSI both. So we can use these IDE controllers in order to attach more virtual hard disks to our virtual machine. So as you can see in here, I have attached this virtual hard disk to this IDE controller 1. And if I want to add a DVD drive, like if I have an ISO file that I want to attach to my virtual machine, I can simply just add that to an existing IDE controller, or I can create a new IDE controller and then attach that DVD with that. If you want to attach a new virtual hard disk to your existing IDE controller, you'll just need to click on IDE controller, then click on hard drive or DVD drive, depending on the drive that you want to attach, and then you will just need to click on add, and you will get your hard drive created in here. Now you will just need to select new, or if you want to attach an existing virtual hard disk, it depends on you. So if you click on new, then it will take you to the wizard where you can create a new VHD or VHDX. So we also talked about VHD and VHDX in our previous video. You can refer to the link in our description for that and get the understanding of how VHD and VHDX work. Now, if you want to change the size of a virtual hard disk, we can go to the hard drive and then click edit option. So once you select edit, then it will take you to this wizard where it will show you the location of that virtual hard disk. Then click next, and then you will need to select the option that you want to choose. If you want to compact the size of this virtual hard disk, in that case you can choose compact. If you want to convert this virtual hard disk, let's say it's a VHDX, if you want to convert it into a VHD, you will choose the convert option. And if you want to expand this virtual hard disk, so right now, let's click next, it will show. Right now it's 26 GB. The size of this virtual hard disk is 26 GB. If you want to change the size and increase it to, let's say, 40 GB, so you just need to give the new size 40, then click next, and you will need to click finish once you choose 40 GB. As soon as you click on finish, then this virtual machine virtual hard disk size will be changed to 40 GB. Now you will need to go to the disk management inside your virtual machine and then initialize the amount of size that we have provided to this virtual machine. Unless you don't initialize the disk on that virtual machine, you won't be able to use the extra 14 GB that you have assigned to it. Next is network adapter. So as we have got physical NICs in case of physical computers, we have got virtual network adapters for virtual machines. We can create as many network adapters and attach them to a virtual machine that we want. So to be able to create another network adapter, we go to add hardware, then click network adapter, and then click add, and that will add another network adapter for this virtual machine. Now once you create the network adapter, then you need to connect it to a virtual switch. In the same way, when we have a physical NIC or when we have a physical computer, we connect it to a physical switch. So we connect the virtual network adapter for the virtual machine to a virtual switch. So for that, we just have to select the virtual switch from the drop down and then click apply. And this virtual network adapter will be connected to that particular virtual switch. You can connect multiple adapters to different virtual switches as well, so that your virtual machine will have access to different networks. And you can also assign the VLAN ID for that particular virtual machine. If you want to keep a particular virtual machine in a separate VLAN, then you can definitely assign the VLAN ID of that VLAN to that VM. Next we have COM ports. So this is basically a legacy thing. So the applications which does not support USB ports, and if they only support COM ports, then we can create these COM ports and configure them as per the settings required by the application. Diskette drive is also the legacy thing for virtual machine, so we are not going to discuss this in this lecture. Next, we can go to the management part of the virtual machine settings, and in here we have got name. So we can change the name of our virtual machine from this setting. Next virtual machine setting is integration services. Integration services is a very critical component of your virtual machine. You will find integration services on each and every virtual machine or Hyper-V host. These are some integration services which are really important in case of virtual machines. Operating system shutdown, time synchronization, data exchange, heartbeat, backup, volume shadow copy, and guest services. Now, these integration services define how your management operating system will be managing your guest operating systems. So if we talk about the first one, operating system shutdown, this is responsible for your Hyper-V host to be able to shut down your guest operating system. So let me show you one example of operating system shutdown. If you right click on this virtual machine, you will find this option shutdown. So if I shut down this virtual machine, it will be turned off completely. So let's shut it down for now, and you will see that it's shutting down currently. Right now the state is running, but as soon as it gets shut down, the status will change to off. It has changed to off now. Okay, and the merge process start, AVHDX starts merging into the parent VHD. So that process is happening right now. Now we saw that we were able to turn off this virtual machine, or we were able to shut down this virtual machine from the Hyper-V host. Now we can go to integration services again, and let's uncheck this, okay, and click apply, and then click OK. So first we need to start this virtual machine in order to test it. Let's first start it. Alright, so right now it's getting started. You can see the state of this virtual machine on this below screen. Right now it's on the Windows screen, so it's currently in the process of starting up. Let's wait for it to completely start up, and then we will test it again. Alright, looks like it's almost up and running. So let's go to this virtual machine again, right click on it, and we will use shutdown in order to shut down the guest operating system. And remember, we have unchecked the integration services operating system shutdown. Let's click on the shutdown, and straight away you will get an error message that says fail to stop. The guest shutdown integration service is either not enabled, not running, or not initialized. That means that because we have unchecked that operating system shutdown option, that's why we are not able to shut down this virtual machine from the Hyper-V manager. So that's how the integration service operating system shutdown works. Alright, so let's go ahead and go to the settings once again, click on integration services, check this box and click apply, so that we should be able to manage the shutdown function of this virtual machine from our Hyper-V manager. Next is time synchronization. Time synchronization is responsible for the syncing of time between your Hyper-V host and your virtual machines. So if you keep this box unchecked, that means your Hyper-V host and virtual machine may have different time within them. So you need to make sure that they should have the same time and keep this box checked. Next we have is data exchange. Data exchange service is used to exchange the metadata between your Hyper-V host and your virtual machines. So if there is any operation which happens on your Hyper-V host and virtual machine, the metadata can be exchanged between your host and your virtual machine if this service is checked. If this is unchecked, then the metadata may not be exchanged, and there may be some difference in the data on your Hyper-V host and your virtual machine. Next we have is heartbeat. So heartbeat service is responsible for monitoring your virtual machines from your Hyper-V host. If you keep this box unchecked, your Hyper-V host will not know the state of your virtual machine. So on the back console, you will see that the state is currently showing off, running, off and off. If we uncheck this heartbeat box, then our Hyper-V host will not be able to check that what exactly a virtual machine state is right now. So if it is running, it won't be able to know that the virtual machine is running. So for that purpose, this heartbeat service is used, and your host keep communicating or keep checking in with your virtual machines in order to see that what is the exact status of your virtual machine. Next we have is backup volume shadow copy. This service, backup technology or volume shadow copy service, is used so that you can take the data consistent backup from your virtual machine. So if you keep this unchecked, your virtual machine will not know that there is a snapshot being taken or there is a backup being taken for your virtual machine. But if you keep this box checked, that means the volume shadow copy services inside your virtual machine will also be working. And those volume shadow copy services inside your virtual machine will help in taking a data consistent backup, because your virtual machine now knows that a backup is being taken, and it uses its own volume shadow copy. And if there are any applications running inside that virtual machine which supports volume shadow copy writers, then it can use those writers in order to take the application consistent backup for those applications. So that's why this backup volume shadow copy option is very important if you want to take an application and data consistent backup. Next we have is guest services. Guest services is used when you want to copy and paste the data in between your Hyper-V host and your virtual machines. So generally this is kept disabled if you don't want to have any copy and paste kind of operation between your host and your virtual machines. So if you need it, you can definitely check this box and use these services. Next is checkpoints. In Hyper-V, we get two kind of checkpoints. One is standard and one is production checkpoint. Now, what's the difference between these? A standard checkpoints may not be able to provide a data consistent backup to us, because when a standard checkpoint is taken, in that case, it takes a snapshot of the virtual machine, but it does not use the backup technology called volume shadow copy services inside the guest operating system in order to take the data consistent backup. So whenever a standard checkpoint is taken, whatever data is there in the memory of a virtual machine, that data may be lost, because that data will not be flushed into the volume before taking the backup. So in the standard checkpoint, you will only get the backup of whatever the data you have onto your volume. If you have something in your memory, that will be lost, or that may be lost because that data is not getting flushed onto your memory before the backup happens. But in production checkpoints, you get the data consistent backup, and it uses the backup technology inside your virtual machine guest services, that is called volume shadow copy service. And it provides you the data consistent backup. How? That whenever you start a production checkpoint, then what it does, that whatever data it has in the memory right now, it first flushes that data onto your volume, and then it stops the input output operations on your virtual machine or on your volume. So in that case, you are getting a data consistent backup, because there is nothing in the memory right now which is getting missed while taking this backup. So you have got backup of whatever you had on your volume as well as what was there in your memory, and your IO is frozen for now. So your data is completely consistent. And once your backup completes, once your production snapshot is completed, then your IO resumes again. So you get the data consistent backup in case of production checkpoints. So as per your requirement, you can use standard as well as production checkpoints. Generally, standard checkpoint is used in case of a test environment, or if you're using a lab, or just to reproduce an issue in a test environment. And production checkpoint is generally used in case of a production environments where we want the data consistent backup and where we don't want to lose any backup due to standard checkpoints. So you can select any of these checkpoints from here, and you will need to keep this enable checkpoints option enabled if you want to use production or standard checkpoint. If you keep this unchecked, there will be no checkpoints created for your virtual machine. So make sure that you have this checked, and you can also change the file location of your checkpoints. So whenever you take a snapshot or a checkpoint of your virtual machine, it will be stored into the location which is defined here. So right now my snapshots are going to DC-2016 and DC-2016. Next we have is smart page file location. This page file for the virtual machine is similar to the page files that we have for our physical computer. We all know that page file is used to reduce the overhead from our physical RAM. So what it does is that whenever there is anything which is being frequently accessed from physical RAM, it is kept in these page files in the cache memory, so that next time when that data will be accessed from the physical RAM, the processor does not have to go to the physical RAM again and again. It can simply fetch it from the page file, and that will keep the operation easy and faster. So that's why page file is used. So in case of virtual machines, these page files are stored in this location. Whatever location you will define in here, that your page file will be saved there. And you can change it from clicking on this browse option. Right now our virtual machine is running, so that's why it's grayed out. But if you want to change it, you will just need to turn off the virtual machine and you will be able to change this smart paging file location. Next is automatic start action. So in here you can define that how you want your virtual machine to start up if there is a crash of your host, or let's say that your Hyper-V host gets shut down somehow. So how you want your virtual machine to act after that. So once your Hyper-V host come back on, should your virtual machine automatically start up, or how it should work? So you have some options in here that you want to do to have it to do nothing once your Hyper-V host starts up, and if you want to automatically start if it was running when the service stopped. So let's say that your virtual machine was running before your Hyper-V host crashed or shut down. So if you select this option, then your virtual machine will be running once your host is back up. And third is always start this virtual machine automatically. So that will make sure that whenever your Hyper-V host comes back online, your virtual machine will be automatically startup. And you can also define the startup delay in here in terms of seconds. Next is automatic stop action. This setting defines how you want your virtual machine to act when your Hyper-V host goes down. So there are three options that we have: save the virtual machine state, turn off the virtual machine, and shut down the guest operating system. So if you select the first one, save the virtual machine state, it will save the state of your virtual machine once your Hyper-V host goes down, so that you don't lose whatever you have in the memory. It will still be kept saved because your virtual machine is in saved state. Second is turn off the virtual machine. So your virtual machine will be turned off if your Hyper-V host goes down, if you select this option, and in that case whatever is there in the memory, that will be lost. And third one is shut down the guest operating system. This will be called the graceful shutdown of your virtual machine guest operating system. So if you select the third one, then your virtual machine will shut down gracefully. Alright, that's it for today. I hope you were able to understand how these Hyper-V virtual machine settings work. We have gone through each and every setting that we have in the Hyper-V Manager console, and we have learned how we can change these settings. In our next video, we are going to talk about virtual machine networking, storage, and some basic infrastructure concepts so that we can easily understand how virtual machine networking and storage work. So let's meet in our next video. Till then, thank you everyone. Bye-bye. Take care.